Eating half of an Amanita bisporigera mushroom does not immediately cause stomach pain, vomiting, or dizziness. It simply sits there pale, immaculate, seemingly harmless, like a creature designed to decorate the forest. 12 hours later, when thirst and fatigue begin to creep in and your liver slowly starts to fail, a silent coup inside your cells has already been completed. There is no blood, no blade, no toxic smoke, only a tiny peptide molecule called amatoxin, severing the communication line of life itself. RNA polymerase II, the enzyme responsible for copying genetic instructions to keep every cell alive. This deadly beauty is not a biological accident. It is the result of hundreds of millions of years of evolution, where fungi became engineers of molecular assassinations, killers that learn to destroy without ever moving a limb. Humans trust their eyes more than any other sense. Yet, in the fungal world, the human retina is a traitor. Poisonous mushrooms such as Amanita, Galerina, and Lepiota often wear pure, gentle colors: white, pale yellow, sometimes dusted with tiny speckles like powdered sugar. That beauty is, in fact, biological camouflage. The bruising mechanism when mushrooms change color after being touched or cut is often mistaken as a warning signal. In reality, it is merely an enzymatic oxidation reaction. Similar to an apple turning brown, iron and phenolic compounds within the mushroom tissue react with air, forming blue or brown pigments. Some edible species like Boletus luridiformis turn an intense ink blue yet remain perfectly safe to eat. Meanwhile, Amanita bisporigera does not change color at all, staying milk white, yet a small bite can be lethal to an entire family. The problem lies within our brains. Humans evolved to recognize motion and contrast, not molecular toxicity. In nature, color carries no moral meaning. It is simply a chemical language. Humans have not fully learned to read. Imagine that inside each of your cells exists a microscopic factory, constantly copying genetic instructions from DNA to produce proteins. That factory is RNA polymerase II. Amatoxin acts like a reverse lock. It slips into the enzyme's active groove and freezes the transcription machinery in place. Once paralyzed, the cell cannot produce new proteins, like a city suddenly cut off from its energy supply. What makes amatoxin especially dangerous is its extraordinarily stable ring structure. Its 8-amino acid peptide chain is locked by a tryptophanine bridge, making the molecule highly resistant to heat and digestive enzymes. Boiling, grilling, or freezing does not destroy it. It is, in essence, a biological dagger forged to never rust. Just a few milligrams can be fatal to an adult. Cruelly, the body may appear normal during the first 6-12 hours, until liver cells, the organs responsible for detoxification, collapse en masse. By then, medicine becomes a race against time. If amatoxin is the silent assassin, gyromitrin is the practitioner of chemical violence. Some false morel mushrooms, such as Gyromitra esculenta, contain gyromitrin, a compound that converts inside the body into monomethylhydrazine MMH, a chemical once used in NASA rocket fuel. The human body was never designed to handle such energy. MMH attacks the central nervous system by inhibiting pyridoxal phosphate-dependent enzymes, which are essential for synthesizing GABA,
Yeah,
the
it's really good.
neurotransmitter that helps the brain
Can I have some more mac
maintain
and cheese,
calm
please?
balance. Without GABA, neurons fire chaotically, seizures, loss of consciousness, and coma follow. Even more frightening, gyromitrin metabolism varies from person to person.
While the plant
Some may
deploys
only
to
feel
the
fatigue,
insect's heart,
while
the
others
fungus
can die within
releases
hours.
aflatoxin.
The difference lies in liver hydrolase enzymes, tiny genetic variations that can determine whether a springtime meal becomes a family tragedy. This story proves a harsh truth with only a slight shift in chemistry. Nature can transform food into rocket fuel inside the human body. Why do some of the most toxic mushrooms taste pleasant and smell so mild? The answer lies in the evolutionary strategies of fungi compared to plants. Plants often use bitter alkaloids to repel herbivores, fungi. However, are heterotrophic organisms that do not photosynthesize. They rely on animals, including humans, to spread their spores. A slow-acting toxin allows the consumer to travel far from the mushroom's origin before symptoms appear, expanding the species' natural dispersal range. In evolutionary terms, pleasant flavor and aroma are perfect bait. Amatoxin does not activate the brain's bitter taste receptors, leaving no sensory warning. Nature does not need to post a "do not eat" sign. The price of curiosity itself has served as a survival lesson across generations. Here lies a chilling paradox. The evolution of flavor may be built upon a foundation of death, and in the silence after a meal, we realize that nothing in nature is truly harmless, only insufficiently understood. Each mushroom is an evolutionary experiment spanning hundreds of millions of years, written in the language of molecules rather than color or taste. They teach us one simple truth: nature has no obligation to display warning labels for human survival. Amatoxin, gyrometrin, and countless other toxins carry no malice. They are merely defense mechanisms refined by time. Humans, proud of their knowledge, sometimes forget that the most dangerous threat is not the toxin itself, but blind trust in our own senses. When science deciphers death at the cellular level, we do more than understand mushrooms, we understand ourselves. A fragile species still navigating the vast biochemical game of nature.